Hello everyone, and we continue with our recording for week 8, and this is part 4, and we are talking about we finished the single loan risk, and now we are talking about the portfolio risk. So in this, we have 4 models. So we'll talk about the migration analysis. We have talk about concentration limit, regulatory what we call treatment, and the MPT, or the modern portfolio theory, which is the last one. Now, they are actually, those models are very straightforward. We will not spend a lot of time on it. So let's talk. We have here the migration analysis, and then we have the concentration limit, and then we have the regulatory models. Let me start with the migration analysis. Migration analysis is a very simple concept, very simple concept. So if this is the rating of beginning of the year, so we have 3 stock, 1, 2, and 3. One of them is AAA, and one is BBB, and one is CCC. I see, so this is the beginning of the year where 100% was here. So 100% of those were for asset 1 was 100% AAA. But during the year, because this class of companies who are AAA, at the end of the year, there will be some type of migration among the rating. So this, for AAA, 85% is still AAA. Now 10% go to BBB, and 0.4 go to CCC, and 1% went to defaulting. So this is immigration that happens. The same thing happened to B. So in B, as you can see, 83 stay in B, because this is AAA, which is actually 1. So this is the 1, and this is the 2, and this is the 3, which means this is 1 is AAA, 2 is BBB, and 3 CCC. So this 183 is still in B. They improved. 12% actually went to A, and 3% went to C, and 0 to 2% defaulting. End of the year also for C, 80% stay, and C, 13% go to improve to B, and 3% went to A, and 4% defaulted. Now, how this information is useful for the company? It is useful like this. So if you see this immigration, which is the classes, all the classes, the average classes moving among the ranking. If you look at your holding as a company, and you see where you stay, if you find that the financial institution is evaluating the credit risk weights current portfolio, and find that over the last year, much higher percentage, say 5%, of loans have been downgraded to C, which means it should be only 3%. But the company find around 5% of it went to C. And then and higher percentage, say 3% defaulted. So the company holding fund, they have 3% defaulted, while it should be actually 2%. So in this case, the company has to decide whether they want to get rid out of their portfolio, because they are already out of range, and maybe they would go and restrict their lower quality loan and continue with higher quality loans. If they are, maybe this be the ones they are holding is not a good portfolio. And this is all about migration analysis. Now let's go to the concentration limit. Concentration limit, the concept of concentration limit means If you are going to invest in industries, so we have so many industries. We have the petroleum industry, we have the IT industry, we have the manufacturing, we have the housing, so many industries. So you have to put a limit how much you want to lose in that industry of your capital. So if you can put that limit, how much you want to lose, then it will tell you how much you should invest in that industry. So you can accept loans until that limit and you stop, because you're already limited how much you are willing to lose in that industry. This is the whole thing. So a manager decides not to lend to any firm and sector that generate losses losses on that part of the loan portfolio in excess of 5%, for example. They can concentrate on that. So look at this example. If you set the maximum, if the average historical losses in industry is 10%, say this is, for example, petroleum industry, what is the maximum loan manager can lend to a firm in this sector as a percentage of its capital, assuming that they are not willing to lose more than 5% of their capital? So this is the limit. So it's the maximum limit how much you should invest from your capital. If the maximum losses you are willing to lose is 5% in that industry, so you divided this one over the loss rate, and the loss rate is 10%, as you can see. This is 10%. Which is actually this 10%. And in this case, you will find that you should invest only 50% of your capital in that industry. If the maximum loss you can accept from your capital is 5%, and the losses rate of this industry is 10%. So the maximum you can invest in that, you can invest mostly what equals 50% of your capital, and then you cannot accept more loans. So they will give loans until you reach 50%. That doesn't mean that you are financing from your capital. It's just the capital will be the buffer of the losses. So this is, and you can do this for each industry. Now the regulatory models, actually, it's a percentage. They have KB model, they have credit matrix, they have credit risk. I think we will talk about this in the in market risk. So maybe we just ignore this for a while. Now the last one is the modern portfolio theory. Modern portfolio theory is coming from, this is what we call investment frontier. So you can build the point behind the MPT, which is modern portfolio theory. They will have the return here, and they will have the risk, which is actually here the standard deviation of the portfolio, and this is the return of the portfolio. So this point, this black dot is actually a portfolio. A is a portfolio and C is a portfolio. As you can see, A, it has this risk, which high risk, and it has this return. If you look at C, it has actually this risk, and it has this return. But the modern portfolio theory, they will tell you, take the least risk and see how much return it gives you. So if you take the least risk, actually B is better than A for sure, because A is risky and giving the same return. For C, it's higher return and higher risk, but the modern portfolio theory, they will tell you put all the portfolios there and take the least risk and match it with the its revenue. So in this case, we are actually talking about this one. So this is when you optimize your portfolio. Modern portfolio theory will do that, and it will tell you how can you calculate all the risk of the portfolios and all the returns of the portfolios. You can bring all your portfolios. This is just, I just choose one portfolio. You can have, computers will do this for you, systems will do that for you. You can have so many portfolios, and you want to put it in the what we call investment foreign tier, and you want to choose this point, which means the least risk, and with its you have to concentrate on the least risk, and you will check how much it's return. So if we have a portfolio of just two assets, 1 and 2, this is the rate, and this is the what you call the weight. 40% of your portfolio is from 1, and 60% is actually from 2. The return of this one is 10%, and the return of this is 12%. And the standard deviation, this is the variance of the first asset, and this is the variance of the second asset, which is the volatility. You can find out the standard deviation, and actually the correlation between the two is -84. Now, we can calculate first the return of the portfolio, which is very simple thing to do. Is just the weight of the first asset times its return, plus the second asset, the weight of the second asset times its return. This is just averaging, and you find it 11.2%, which means in this case, if you hear the 11.2%, 11.2 will be here in this point. We are talking about this portfolio. If this is the best portfolio, okay? Now, you will find the rest. The rest you can get it from this formula, which is you have to bring all your assets, square them and multiply them by the variance, and then add them, multiply by 2, and add them up, multiply the two portfolios by their standard deviation. So I will start with first asset times its standard deviation plus second asset squared. All of them are squared times its standard deviation. And then I will bring the 2 times the weight of the first one, weight of the second one, times the correlation between the two assets, which is this one, and then times the standard deviation of the first one, which is this one, this number, and the standard deviation of the second one, which is this one, and then we will find this one. So this is the risk. So if you want to come here, this risk, which is 0, 0, 1, 2, will be here. This is, which is this one, 0, 0, 1, 2. I'm just using this cruiser and not, okay. And this is the, can be if this is the best portfolio, if this is the best portfolio. Otherwise, you keep calculating the portfolios until you find the least return, and you match it with its return, the least risk, and match it with its return, and you can put it in the portfolio. This is the end of part 4, and I will continue later on in the second part. Thank you very much, and I will see you in the 5th part.